Here we are on page 10. We're going to be dealing with circles now. Now, we did a little bit on the coordinate plane with circles with equations of them. Now we're going to go into their geometry, radii, diameter, circumference, all sorts of things. So, as a review, from the radius to the diameter, we're going to double it. So that's going to be nice. Circumference, the formula is 2 pi r, and area, pi r squared. Also, circumference is pi times the diameter, so we'll be able to do that. Radius is 5, diameter is 10. Circumference then is 10 pi, and area will be pi times the radius squared, or 25 pi. Certainly you can plug those into your calculator and you'll be like, oh yes, I get that. And you'll get decimals. So the diameter is 11, that means the radius is 5.5, or 11 halves. Circumference then is going to be 11 pi, and area is 5.5 squared times pi. So that's going to be 30.25 times pi. That's kind of not common, so let's go ahead and punch that in to 5.5 squared. Yeah, 5.5 squared. And you'll see there's the 30.25. And then times second pi, and often you'll be asked to use the 3.14 approximation, but about 95.03. All right, let's go backwards on this one. We're given the area, so we've got to undo pi, and so we divide by pi and then square root, so the radius is square root of 33. Diameter would be 2 square roots of 33, and you can punch those into calculator, get those right answers, and then 2 square roots of 33 times pi, or 2 pi square roots of 33. There we go. Ooh, circumference is going to be a little bit tougher. If we divide by 5, pi, 27 over pi, that better be the diameter. Let's go ahead and do a decimal on this one. 27 divided by pi gives us 8.59. So 8.59 is the diameter, and the radius is going to be half of that. So divide that by 2 and we get 4.30. Now for the area, we've got to take this guy and square it and then times by pi, and we get 58.01. There we go. Okay. Number 5, solve the following figure for the given values. So we'll do 5 in the color red, and then we'll do 6 in a different color so we can use the same figure here. It says AB is 7. All right, so if AB is 7 and CD it gives us as 3, and EG it gives us as 5. Now the thing about a circle is a radius is constant, so that means AE is also 5. Oh, that was nice. And if we're 5s from E to C as a radius, then from E to D it must be a 2. Oh, this is nice. This is how this works. So we got a 7 here. BF is also going to be a 7. It's the radius. BC then, if it must be a 4, so that this can be a complete 7. There we go. That wasn't so bad. So it's just adding and subtracting and seeing that a radius is constant all the time. Let's use green for number 6 so we can tell the difference here. So we don't have AB, but we do have BF is 13. And we can see that, yeah, that makes AB 13. Oh, that's nice. BC is 8. So that gives us that CD has to be the other 5 of the radius of this big circle. DE is 3. So if this is 3 and this is 5, then this smaller radius is 8 everywhere. So yeah, that means EG and EA both at 8. So that's just a practice in the radius being consistent no matter where it is and being able to use that. Good. Let's go down to number 8. It says that AD is 5. So we have the radius of the circle is 5. Now this has M. M means degree measure. So the measure of angle BDC is 31. And the trick here is that this central angle is the same as this arc measure out here. So those two are the exact same things. So when we get BC, notice it's not asking for the measure of arc BC, but we're going to have to find that actual length there in just a minute. as arc AE, and so on and so forth. So the measure of arc BCE. Now the measure of arc, so going around like this, from here all the way around like that, has to be 180 degrees because BE there is a straight line. So that's one we can get with degrees. Now the rest of them, we've got to look at this. We're going to find areas and perimeter. So let's get those first. So the area is going to be pi r squared, which in this case r is 5, so 25 pi. And the perimeter, or the circumference of the whole circle, is 2 times pi times r. That's 10 pi. Now let's get approximations here. 25 times pi, that's going to be 78.54. Okay, and 10 pi, we know that one. 3.14159 times 10 is 331.416. There we go. All right, so that's the perimeter and area of the whole thing. Now if we look at this guy, arc A to E, this is 90 degrees. So we've got to take and divide this guy by 4 in order to get arc measure of AE. So let's do that. Let's take, it was at 10 pi, and we divide it by 4 because we're a quarter of the way around the circle, and we get 7.85 for arc AE. 7.85. Now we could have kept it exact. We could have gone like that, and that gives us 5/2 pi. That's okay too. Now arc BC is going to be a little bit different. It's 31 degrees. So here we're going to take 31 3/60ths of the circle and times that by the circumference, which was 10 pi. Let's punch that in. 31 divided by 360 times 10 pi. And we get 2.7. That's arc length on BC. Now BCE is going to be exactly half of, measure of arc BCE. Holy cow, that's 180 degrees, so it's better be half of the circumference. So I'll just put that down as 5 pi. We can do that one in our head. 10 pi divided by 2. Now, the shaded region, if we're going to do the area of this, first of all, we've got to find out what degree measure is in here. And if that's 31, then this is going to be 149 degrees. So we're going to have 149 3/60ths times the perimeter. That's going to be the length along here, and 149 3/60ths of the circle times the 25 pi. That will be the area in here. So we get the area of the whole circle and then take 149 3/60ths of it. Let's put that in our calculator. 149 divided by 360 times 25 pi. Let's see what we get there. 32.5 for the area. And that would be like in inches squared or centimeters squared. And the other one, 149 divided by 360 times 10 pi. And what do we get there? 13, almost exactly 13. There we go. So this is how we use our radius and our angle measures to get actual sector areas and sector circumferences. Oh, we messed up. We're not done here. This out here is 13. Better change color so you can see what I'm saying. This out here indeed is 13, but we forgot to go there and there to get the full perimeter of the shaded. So we've got to add 5 for DC and add 5 for DE. That's the radius of the circle. So this is really 23. Whew, almost messed that guy up. All right, number 9. Let's clear off a little bit of space first. All right, with number 9 here, it says AD equals 28. Oh, that's a much bigger circle. Measure of arc BDC Good, that's 21 degrees. So this is going to be 21. Let's fill out what the rest of these are. This is 159 degrees. So this arc measure here is 159. BCE, that's still 180 degrees. Can we get any, measure of arc BC, that's going to be 21 degrees right there. This is with the arc measure. Good. Anything else that nope, the rest we're going to need to get the area and the circumference. So let's get that out. Area is going to be pi times 28 squared. Ooh, that's a big number. Second, pi times 28 squared is going to be 2463. Almost exactly 2463 inches squared, centimeters squared, whatever it might be. Circumference is 2 times pi times r, so that's going to be 56 pi. Also a big number, but I'll leave it like that so we can stick it into our calculator in just a bit. So there's the circumference. So measure of arc BC is 21 degrees. Arc length would then be, so BC arc length is going to be 21/360ths of the circumference, which is 56 pi. Plug that in, 21/360ths times 56 pi. And that is 10.26. Okay, arc AE. That is arc length. We know it's a 90-degree measure, so it's 90 out of 360, which is 1/4, times 56 pi. So 1/4 of that, oh, hey, we can do that. 1/4 of 56 is 14. That comes out to be nice, 14 pi. And measure of arc BCE, is 180. So arc length of BCE is going to be 56 pi, and now we're going to divide it by 2, so we get 28 pi. So arc length of BCE is 28 pi. All right, let's try the area of the shaded region. So we've got 159 degrees, and so the area of the shaded region would be 159/360ths of the circle. That's how much we have, times the whole area. So 2463 is everything, and we just want 159/360ths of it. 159 divided by 360, that would be the percent of the circle that we have, and then times that by 2463. And 1087.8. 1087.8. And the perimeter of the shaded region, we've got to get arc length BC first. That's going to be 159 over 360 times the circumference, which is 56 pi. That'll give us the distance around the outside from E to C. 159 divided by 360 times 56 pi is 77.7. Now notice that is not our whole perimeter of the shaded. We still have a 28 here and a 28 here. So 28 plus 28 plus that. So add that to 56. Plug that in, add that to 56, and we get 133.7. So notice this is going to be an area, so that's in inches squared or centimeters squared, and this will be in inches here. Good, okay, the last one. We don't have a lot of things to find on number 10. All we're doing here is finding some arc lengths and whatever. So AB equals 5. All right, number 10 down here, we're going to find the measure of arc AB. So we've got to get some angles in here. Length of arc AB. So we've got to have the perimeter in order to do that. And then X to find this distance across here. Well, if this is 130, we know that the radius is 65. So we get this straight line here at 65. Now, this guy coming and cutting this guy right in half gives us a 60. So we can do 60 squared plus b squared equals 65 squared to find out this length right in here. Or you can recognize that this is a 5 times 13 and 5 times 12. 13 and 12 and another number made a Pythagorean triple perfectly, and it was a 5. So this is going to be a 25, but let's just double check. And 65 minus 60 squared, let's pull out the calculator for that. 65 squared minus 60 squared, that equals 625. Yeah, b squared equals 625, and if we square root that, b is 25. Good, good. All right, let's try the next one over here. If we stretch this guy out on a straight line at 65, and this guy is a 39 when we come in here, we have 39 squared plus b squared equals 65 squared. Okay, let's try that. 65 squared minus 39 squared. Some of you may notice that those are all multiples of 13, which means, hey, wait a second, maybe it's a Pythagorean triple that comes out nice. If we square root that guy, ooh, 52. Yes, this is a 3, 4, 5 triangle all multiplied by 13. So that's a 52. So we actually found x first, which is 52 plus 25 gives us 77. So x is 77. All right, so now looking at this, let's see if we can find these angles down here. How are we going to do that? I'm going to keep and draw this guy down here. Let's see if we can find this angle right here. So this is going to be, will be the same angle as that. So looks like we're going to use sine, cosine, or tangent. So we can use, call that theta. Sine of theta equals 60 over 65. Let's find out what that angle is right in there. Calculator, sine inverse of 60 divided by 65. That equals, this is a 67.4 degrees in here. 67.4. Let's put that there. Theta is 67.4. Okay, now let's find out what this guy is on the other side. Notice we can get that same angle right here as there. So if we call this guy alpha, then sine of alpha is going to be 39 over 65. So let's get our calculator out. Second sine inverse of 39 divided by 65. What does that equal? 36.9 degrees over here. Alpha is 36.9. All right, so if we have 36.9 and 67.4, and we add those two together and subtract from 180, we should be able to get this angle right in here. So 36.9 plus 67.4, so plus the 67.4, and then subtract that from 180. I'm subtracting backwards, so I should end up with a negative number of what it really is. So 75.7 is this arc right here, 75.7. Let's go ahead and put that in there, 75.7 degrees. Oh, yeah, that's an angle measure, a degree measure, I should say. All right, and now for the arc AB. Arc AB is going to be 75.7 out of 360 times, so this is the portion of the circumference, which is 2 times pi times the radius, which is 65. All right, let's see if we can stick all that in. 75.7 divided by 360 times 2 times pi times 65. So that will give us 85.88, 85.9 inches or feet, or however they're measuring that circle. All right, good.